All right, so like and subscribe, good to go on that. Let's talk about inverse trig functions today. So, as a reminder, essentially what we're kind of working with is that, like sine to the -1 power, the cosine -1 power, and tangent -1 power. Now, typically, right, you've seen questions like this, right, and this is typically where we use those inverse trig functions. Problems like this where we are trying to find the angle when we're given some of the sides. For example, on this problem, we would go ahead and say, well, if I wanted to find x, right, I know the sine of my angle because of the information that I have here. I know the sine of my angle is equal to the opposite, right, this is my opposite side, over my hypotenuse. So this would be, the sine of x is equal to 10 over 30. And then in order to solve this problem, right, in order to get x by itself, right, that's always the goal here, we could do inverse sine on both sides. So we're going to do inverse sine of that, and then inverse sine here, right? We apply that to both sides, and then maybe you have no idea what that is, but essentially these cancel, right? And then you get x is equal to sine inverse of 10 over 30, and then you get out an angle, okay? Now that actually brings up an important point that we will kind of talk about later. But you got to make sure you're in degrees mode from here, right? And then you do sine inverse 10 over 30, right? And you would get out that 19.47, right, is your x there, all right? In other words, your angle. So, and just to show you, right, if we were to put that 19.47 in, right, so sine of 19.47, we should get out that 10 over 30, and we do, because that is a decimal version of that. So, regardless, this answer here, right, your angle here, it's going to be 19.47, an approximation, okay? So, that is your exposure kind of so far from sine inverse, cosine inverse, and tangent inverse. Now, it could be sine, cosine, tangent, depending on what you're given when you're compared to that angle. But so far, that's what we've dealt with inverse trigonometry. Now, let's get into some more details about all this. And we're going to actually explore the graphs eventually, and then some more problems that could potentially come up with trigonometry or inverse trig problems. So regular trig functions, right, your input is an angle, right? So like sine, cosine, tangent of an angle, and then we get out a ratio of sides, okay? And like we have here, right? It's always, sine of an angle equals the sides, okay, or the ratio of the sides. Inverse trig, right, is flipped, right? Inverse is, your input's now your output's now your input. That's exactly what we have here, right? So the inverse trig functions, input is the ratio of the sides, right? Notice it was the output earlier, and then your output is an angle. As we can see here, right, sine inverse of 10 over 30. What is 10 over 30? Well, 10 over 30 are ratio of sides. So my input here is ratio of sides. My output, what did I get out, right? What did it end up equaling, right? This is sine inverse of the ratio of the sides, and it ended up equaling an angle, okay? And that's what that 19.47 is here. So that stays consistent with what we know. A few more pieces of information about inverse trig. Now, just so you know, you may see it as arc sine, or you could see it as sine inverse. Okay, so like I said, you may see it as arc sine, or you may see it as sine inverse. They're the exact same thing. Okay, same with arc cosine, cosine inverse. Right? It's just another way of describing it. Okay, so arc tan, tan inverse, exact same thing. This is just notation. Okay, this is just notation. And so it is important to note, though, right? Arc sine or sine to the -1 power, or sine inverse is how I kind of call that, is the inverse of sine. Okay, and again, inversing, right? When you have inverse, it's the input is now the output, and the output is now the input. It's switching your inputs and outputs. All right. So for an example, okay, as an example. Okay, just to show you the inputs and the outputs and all that. So we know, okay, based on our unit circle, I need some more lead, hang on. All right, based on our unit circle, we know that the sine of 60 degrees is equal to the square root of 3 over 2. As a reminder, right, we've developed our unit circle before. Sine of 60 degrees. Zoom out so we can see it. Sine of 60 degrees, so I would go to that 60 degrees, right, which ends up being pi over 3 in radians. And we're going to look at my y. So I do have the sine of 60 degrees being the square root of 3 over 2. Okay, so that we know that, right? We've developed that. We've worked with that before. Okay, so sine of 60 degrees is equal to the square root of 3 over 2. And we also know that sine is the opposite over my hypotenuse. Okay, so if, essentially what this is saying, what we know, right, is if my opposite side is the square root of 3, then my hypotenuse would have to be 2. That's what sine of 60 is telling us. Okay? If this is true, okay, if this part is true, right, which we know it to be, okay, it's also true that arc sine of the square root of 3 over 2 is equal to 60. Okay, 60 degrees. All right? Or you could write it as sine inverse square root of 3 over 2 is equal to 60. Okay? So again, you have to be careful with your input and your output. Okay? So here, this is an angle. Okay? Here, this is a ratio of sides. Okay? So that's exactly what we are looking at, right? It's the angle here, but now, right, with arc sine, inside is the ratio of sides, and then out is the angle. Okay? So you are flipping these two, essentially, right? And you have to think about, again, what they are. What you're inputting is an angle for sine. You're getting out a ratio of sides. Now with arc sine, you're inputting a ratio of sides and you're getting out an angle. Okay? Cool. Now, let's talk about the graphs. Okay, so now that we have kind of a general idea of what those are, let's go ahead and talk about the graphs of those. Okay, so let's go to Desmos and let's explore a little bit. So let's just go ahead and start with just our y equals sine of x. Okay, so what we have here now, you're going to notice something a little bit different. We're kind of used to seeing like a 1 and a negative 1, right? And technically that's what we do have here. Okay, so just understand that. I mess with the scale a little bit. You'll see that I have pi over 2 here, pi, etc., right? And that's because the goal here is to talk about the inverse. All right, but regardless, we've got y equals sine of x. So we know that graph, right? It continues on forever. We've graphed this before, right? You can scroll over here to really see that good picture where it starts at that bottom and then continues, right? And that value is going to be your 2 pi, right? Ends, one period starts at 0, ends at 2 pi, right? That's what those values are from. Okay. Now the inverse, if you remember, we've talked about inverses before, right? Where we are, here's a function, graph the inverse, right? And the first thing we'll do is we'll switch x and y, and then we end up solving back for y. So this right here, right, is actually our inverse graph. Okay, so let's go ahead and look at that, and let's see what happens, right? Remembering, right, you should remember that it's essentially a flip over the y equals x line. So if I were to draw a line here, y equals x, it's going to be a reflection over that line. Now, it's not going to be, I don't know, we're so used to being, y equals x looks exactly like this, but because of the scaling, it's going to be a little funky, okay? So keep that in mind. But regardless, we should see something, right? This is going back and forth along the x-axis, so we should expect something in here, all right? And there we go, okay? That is our inverse, okay? Now, here's a problem. Or the problem with this is, in order to be a function, right, in order to be a function, you have to pass the vertical line test. So if I were to put a vertical line here, I should only see one point, okay? So vertical line, 1 point, right? Vertical line, 1 point. But we do not have that with this. So there lies an issue, right? For a function, we need one output for every input, okay? And we do not have that with the vertical line test. So that's a problem. And we're going to run into that problem with sine and cosine, okay? So what we end up doing is we actually restrict the domain. So we're going to end up restricting the domain, and we're going to say so for example here, right? We have a repeat, right, at here and this point, right? When I plug in -1, I get out negative pi over 2 for my y. When I plug in -1, I also get it 3 pi over 2. And the reason why this is, right? It's the whole idea about the 360, right? If I go all the way around, if I add another rotation, right, the 360 degrees, I'm coming right back to the spot that I was at in the unit circle. Okay? So for example here, oops, can't see that. So for example here, right? So here I am, here's my 1, right? And if I go all the way around the circle, right, and I add 360 degrees, we know that the sine of 90 is 1. But also the sine of, let's see, 450 is 1, right? Because 90 plus 360. Okay, so that's the problem. We don't want more than one output for every input. Okay? So we restrict the domain here. And we've seen this elsewhere. Okay, we've seen this elsewhere where we have to restrict the domain. All right, so we're restricting the domain, and we're actually going to get rid of everything. This is arbitrary, right? This is, mathematicians are exploring, like, where should we let's make this consistent? Where should we knock it off? Well, it makes the most sense to chop it off here and here, okay? And that's what we do. Actually, no, sorry. This is the one where we chop it off elsewhere, you'll see. Oh, no, I was right. Negative pi over 2, 2 pi over 2, right? And so that helps us get rid of the the vertical line problem, right? Where we've got one value or one output for every one input. Okay, so we restrict our domain, and now we should have no issues. Okay, so that ends up being the graph of arc sine. Okay, now if you notice, these two are the exact same. It's just that when I flip it, it doesn't restrict the domain, but when I put it in as y equals arc sine of x, it does have that restricted domain. So this is actually the graph of sine inverse. Okay, let's look at cosine. Here's cosine going along the x-axis. Okay, the inverse should be going along the y-axis, and we see that. Okay, but we run in that same issue of I want my domain restricted because I want one output for every one input, and it does not pass the vertical line test. So that's a problem when we're talking about functions, because we want, again, one input, exactly one output. And that is where we will restrict the domain there. Now this one's a little bit weird. Let's look at sine and arc cosine. Okay, so sine is this green one, right? And then arc cosine is the red one. So you see how we go from 0 to pi for arc cosine, but then a negative pi over 2 to positive pi over 2 for arc sine. All right. Again, that is sort of an arbitrary decision. Hang on, let's see. Okay. That is sort of an arbitrary decision, right? But if you think about it, like we could have taken any section that was from like 0 to pi, right? So like if I went, started here, well, that one doesn't work. But there's other sections that do work where it's got a vertical line. Like for example, I could have picked, here to here, right? But the easiest one to work with is one that's closest to the x-axis. So that's the one we keep from 0 to pi. So there is our arc cosine graph. Let's talk about tangent. So tangent, here it is. Looks probably a little bit different than what we're used to. I don't think I showed you guys the repeating of tangent, but it does repeat just like sine and cosine. Okay, so we've got the repeating in here. Inverse is going to look like this. Now here's the funny thing about the inverse. Okay, let's think about the vertical line test here, right? Where it runs into issues on this is the repeating, right? Like this doesn't. So let's just look at one little piece, right? So this is this in here. Okay, if we're looking at this piece, that little piece just by itself actually passes the vertical line test. It's where it starts to repeat, where I'm up here, right? Okay, now it doesn't pass the vertical line test if I use that one. So this one's a little bit different, but we just get rid of those other ones like that, and that is tangent. Okay. Now this one actually has an asymptote, and I'm gonna show you that in a sec. But this one has an asymptote where it actually does not hit negative pi over 2 or pi over 2, which makes sense because we had that asymptote with tangent as well, right? Where we were graphing that before. As a quick reminder, in here, right, where you have the asymptotes. So you still have asymptotes, okay? It's just they're horizontal for your arc tangent, okay, for your arc tangent or your tan inverse. Okay, so that's what the pictures look like. Let's go ahead and put it in the actual notes. Here we go. So we are here. This is the last page of your little booklet. Okay. All right. So inverse cosine. Inverse cosine. Okay. Inverse cosine. It's got a point here. It's got that point up here. It's got the point here. Okay. So it looks like so. Where we are. I'll just show you real quick. So we're starting with this. Okay, so we've got something like that, and that's what we're going to copy right here. Okay, and let's zoom in on that. All right, so something like that. Okay, the notation. Remember, you have two options. This is what we've talked about before, right? You got cosine inverse or arc cosine. Okay, arc cosine, either one. The domain. Okay, so if you remember on sine and cosine, right, they just continued on forever, right? But this, we restrict that domain. So the domain that's restricted, I just want these little parts in here. So -1 to 1. Okay, and then the range, because of the restricted domain, ends up being 0 to pi. Now, notice these are brackets. Okay, that point actually exists, right? This point and this point. Those work, right? Those are real points on those graphs. All right, now here's an interesting thing, okay, that we need to kind of talk about. When we're working with inverse cosine, okay, inverse cosine exists from 0 to pi, okay? Inverse cosine exists from 0 to pi. So let's show where that exists on the unit circle, okay? So I'm using pink here. I'm also going to use pink here. So this is where your inverse cosine exists with that special restricted domain. So, in other words, if I get a value, right, or if I'm looking for an output, right, those are my only options. Okay, so if I put in anything for inverse cosine of whatever, okay, first of all, it's got to be within that domain for it to be defined, okay, but the outputs, the only ones that are allowed are going to be from 0 to pi, okay, and we'll get into the details later, but for now, inverse cosine exists in here, all right, inverse sine, so here we go on this one, we've got this, that. Okay, inverse sine. The notation, sine inverse or arc sine. Either way, arc sine. Domain, also restricted from, but this time it's -1, it's the same as the top, sorry, -1 to 1. The range is different though, all right, so it goes from -pi/2 to pi/2, so that is different. So this arc sine, or inverse sine, exists in a different spot. So it exists from -pi/2 to pi/2. So that's in here. All right, let's get ready for this. We're going to do like a little curve like that. Okay, that exists in here. Okay, it's the outputs allowed are from -pi/2 to pi/2. Okay, within that domain. All right, and we need to block off this with brackets. Bracket, bracket. Okay, just like we did up top. All right, so those are the values allowed based on that restricted domain. Inverse tangent. Again, we'll get into those details. Inverse tangent. Okay, let's start off with the asymptotes, actually. Okay, so top one asymptote at pi/2, and then an asymptote at -pi/2. And your tangent graph looks like that. Arctangent graph, that is. Okay, something in there. Notation, tan inverse, arctan. Okay, domain. All right, the domain here is actually everything. Like all real numbers, right? Look at my arrows, right? X domain is all your x's that are allowed, so negative infinity to infinity. The range, okay, it is a restricted range, and notice I put parentheses here. I also put parentheses here because of the asymptotes, okay? So it goes from negative pi over 2 to pi over 2, okay? So that's the same range, right, as this in here, okay? All right, so here we go. Same little circle because it goes from negative pi over 2 to negative pi over 2 to pi over 2. This one has parentheses, though. Okay, those are your allowed values. Okay, we will get into the real details about this whole thing later. Okay, but for now, just understand your outputs, your answers for inverse cosine are going to be in here. Okay, your answers for inverse sine are going to be in here, right, with the green. Your answers for inverse tangent in here. All right, and then to talk about the quadrants, what quadrants they're allowed in. Let's get a quick review of the quadrants. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, using Roman numerals there. So with arc cosine is pink. If x is positive, the angle is in here. So what that's saying is if my x is positive, right, it is going to be in this quadrant up here. So here's your x, right? It's in quadrant 1. If x is negative, over here. Okay, in quadrant 2. Okay, and then over here, right, and this is your, with your, oh, I lost my train of thought. Okay, sorry, I got my train of thought back. So, the x is positive situation, right, is where your ratio is positive, okay? So if you think all in here, let's go to the unit circle just so you see it. Right? Your cosines in here are all positive, okay? Positive, positive, positive. Okay? So, but over here is where they're negative, 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 negative. Okay? So when your input, right, x is your input. When your input is the ratio of the sides, your angle will be in that quadrant 1. Okay? Your angle will be in here. Sorry. If your x is positive, let's just start over. If your x is positive, here, here, and here, it's going to be in quadrant 1. But if your x is negative, here, here, and here, it's going to be in that quadrant 2. Okay? Let's continue with sine. We can see the pattern. When your sine is positive, which is going to be here, here, and here, but note it's also positive here, here, and here. But we're not using this quadrant, right? We're not going there, right, because of the angle in here. We're deciding to go with this as our domain and range. Okay, so positive, you're going to stay in quadrant 1. But when x is negative, so when your input is negative, now it's negative here, right? Negative, negative, negative. You're going to use this quadrant. Okay? So that's quadrant 4. Okay? And then with arc tangent, you've got quadrant 1 up here, quadrant 4 in here. Again, we're going to get into those details further as we move forward here. Okay? All right. So let's take a look at some problems. We're going to keep that handy. All right. So we're going to use the unit circle to kind of help us out here. I'm actually going to pause it. I'm running too close to class.